Hey guys, it's Miss Adams, and we're still looking at the Unit 10 test review. We're on problem 5 now, and we're going to be looking at some different ways to convert quadratic equations in between vertex and standard form. And then we also want to look at how that relates to our graph. So we're going to be graphing these functions as well. For problem A, we're given x squared minus 6x plus 48. So we're given standard form. Key characteristic from standard form there will be the y-intercept. So that's 0, 48. And now we need to complete the square in order to convert from vertex to standard form. Or excuse me, standard to vertex form. So I've got to first identify my b value. In this case, my b value is a negative 6. So I'm going to do negative 6 divided by 2. And negative 6 divided by 2 is going to give us the value of negative 3. That negative 3 is important, but then we find our perfect square from that. Negative 3 squared is going to give us a positive 9. From here, we're going to isolate our variable term. So we've got x squared minus 6x, and we're going to add to that our perfect square. We still have the positive 48 as our constant at the end, but since we added the 9, we also have to subtract our perfect square 9 from the end. From here, we can simplify a little bit. So that's going to give me x squared minus 6x plus 9. And then I've got 48 minus 9, which is going to give me 39. So plus 39 at the end. And this is now a special squared trinomial. So I've got x squared minus 6x plus 9. I can factor this to become x. And I'm going to take that b divided by 2 term, which is negative 3. So x minus 3 squared plus 39 is going to be my vertex form. From that, I can find the vertex at 3, 39. Now, guys, this isn't the cleanest function to graph. So let's go ahead and look where our vertex is first. So I know the x value is 3, y value is 39, so it's going to be a little bit under the 40. Guys, if it's not perfect, that's okay. And then our y-intercept is going to be at 0, 48. So we can find some other key points needed by plugging this into the table function of our calculator. So I'm going to plug in x squared minus 6x plus 48. And I'm just going to look at some other points here. So I know when x is 0, y is at 48. When x is 1, y is at 43. When x is 2, y is at 40. When x is 3, that is our vertex at 39. And that's going to come back. So when x is 4, y is 40. And then when x is at 5, y is 43. And we can even look at when x is 6, y is going to be that 48. So this is a wider parabola, but that's okay. It's still a parabola, so we're good. Let's look at the next function. It says y equals x squared minus 4x minus 2. So this one should look a little bit more normal. We've got our y-intercept from standard form is 0, negative 2. So we can go ahead and graph that point. And then we're going to complete the square. So I've got my b value is negative 4, so I'm going to do negative 4 divided by 2 squared. Negative 4 divided by 2 is a negative 2. Remember, that sign is important. It'll affect our factored form there at the end. And then negative 2 squared is a positive 4. Rewriting this function, I've got in parentheses x squared minus 4x. And I'm going to add to that my perfect square term of 4. Then minus 2. And since I added that perfect square term of 4, I'm going to subtract that perfect square term of 4. Combining like terms gives me x squared minus 4x plus 4 inside my parentheses, and then negative 6 outside the parentheses. And my vertex form of this now is going to be x minus that 2, which is my b over 2 term, squared minus 6. That gives me a vertex at positive 2, negative 6. So I'm going to look here. I've got positive 2, negative 6. And I can plug this function into the calculator using the table function. So I've got x squared minus 4x minus 2 And I can find some more points here. Let's go ahead and look about where x is 1. When x is 1, my y value is -5. When x is 3, my y value is -5. And when x is 4, my y value is -2. Which gives us our parabola. Alright guys, stay tuned for the next video.